Afternoon all. Postbag. Okay, what do we have here? Right, this is part of the Arduino system, the APM Arduino Mega. So it's another one of these purple boards, and on the board is a giant resistor which says 0M50. What could that be? It's certainly a very low resistance and capable, by the looks of things, of taking quite a high current. Now there's not much else on here. Looks like there may be a regulator and there's a diode, and then this connector goes to the flight control board, and then what you do is you wire these bits of wire on and these connectors, and the battery comes in here, goes out here, and this is measuring the voltage and the current and sends that information to the Arduino flight control computer. Good, I'll have fun with that. Now this one is described as microprocessor, so I have a feeling this could be the Arduino, and it is the Arduino, clone of course. Now this is an Uno. Let's open this up. Yes, this is the Uno using the CH340 as the USB to serial chip. Now interestingly, it's got a full-size 80 mega 328p DIP version. There's two keys, key L and key H, and two pins there, so I guess these are so that you can implement two little push buttons for whatever you might want to do. There's an ISP header, but there's also a USB ASP 10-pin header, so that you can program this using a US BASP, as I call it. A sort of vague hint of Arduino-ness on the back, but clearly it's not a genuine one. So it'd be interesting to see that up and running. The CH340 certainly seems to be a well-behaved chip, not needing drivers for Windows 8, possibly does need them for Windows 7, so I'll try that out a bit later on. So I've plugged this in, and D13 LED is switching on and off at 1 second intervals, so that's appears to be working. I just want to see if I can talk to it without too much drama. So let's go to Arduino. I've changed the blink delays to 100-100. So now let's try to set this up. What am I doing? Tools. Board is the Uno. Port is COM5 by the look of it. And let's compile. We'll upload. See if this succeeds. And there's a very rapid flashing D13 LED, so that appears to work fine. So this is an Uno clone with the CH340 instead of the 16U2 for the USB to serial conversion. You can have blue or black. It was $4.99, and this came from Toy Model 55. Okay, another big one. Now this was recorded delivery, but I think from the shape of it, I know what it is. I can't understand quite why it would be recorded delivery, because it was very, very cheap. So this is the CMP12 solar charge controller. And I can see already that this is a different layout inside to the other one that I've got of these. So let's have a look inside. So yes, the heatsink arrangement is different. That's using, by the look of it, those unmarked MOSFETs again, which is interesting. And they've got rid of the polyfuse and put in one of these fixed fuses, which is a real shame, because the polyfuse is automatic over current protection, this fixed fuse means that you'd have to fiddle about and solder in a replacement. That's a real shame. Now, if you know your CMP12s, you might feel slightly aggrieved that this is a CMP12 and on the picture it says CMP12/24. The one I've received doesn't have the polyfuse, but the one in the picture, there is definitely some yellow behind the grill there. These are stock images, so it's not surprising. Now it does, although it's a CMP12, it does say on the back voltage 12 volt/24 volts. So I suppose I could test the 24 volt thing at the risk of blowing it up. Why not? But in any case, a solar charge controller, even a basic one like this, sent recorded delivery for £4.43. That's not really bad, is it? Okay, this one has some nice Hong Kong stamps on it and says LED Driver. So let's have a look. Why cut the stamps up? And it is indeed an LED driver. I'll get it out the bag. Now, this is a little LED driver for an MR16 lamp, and that's a 12 volt input lamp, but 12 volt AC or DC. So you can see that the first thing that happens is that 12 volts goes through a bridge rectifier. Now, on the top there's a PT4115 LED driver chip, which I've played with before. The inductor, the capacitor, and then on the back is the Schottky diode and the little current sense resistor. And can we see what that says on it? Yeah, R100, so that's presumably 0.1 ohms. Now the seller of this device has very generously given me all this information, so I will keep this in the bag. So this is a 10 watt, this is for a 10 watt LED. The one that is a 3x3 matrix, 950 milliamps, constant current 12 volt driver. The forward voltage between 10 and 12, that's the output. There's the current again. So this is for driving 10 watt LEDs. Let's get one. Now you've got to be slightly careful with 10 watt LEDs because there are two types. There's the 3x3 matrix. So that's not that type. So this is the 3x3 matrix, so it requires about 9 volts to drive it, slightly more. A 9 volt battery just lights it up, not terribly bright, so you can identify that's the positive. But this one is a single array of 9 LEDs all in series, so this is going to require more like 30 volts or 27 volts to drive it, so of course nothing happens if I try and power it from a 9 volt battery. So I've wired the driver up to the 10 watt LED. This is my 12 volts coming from my battery bank outside. So I put one of the pins into the center of that, and then I'm just going to touch the other one to the outer, and that lights up fine. So yes, that is a perfectly good working driver of 10 watt LEDs. Now what I'm trying to do here is I'm trying to find the cheapest and the simplest way to drive different wattage LEDs directly from 12 volts, and this is certainly cheap. It was £1.29, and this is perfect because this drives that 10 watt LED with ease. No fiddling about setting up the current because it's all predefined in the driver. For a new series to well, I started a series on how to drive high power LEDs, and I want to really restart that, but do it much simpler and much cheaper. So this driver module, 1 times 10 watt constant current 12 volt driver for just £1.29, no postage of course. This one came from OLED.com, and as I say, got this nice data set on the bag, so that's a nice item. Okay, here's the last one. I'm whipping through these quite quickly at the moment. Okay, so this is... now this is an OLED, and it's just 4 pins, so this is I2C. A little bit more difficult to drive I2C OLEDs But the reason I bought this one, this is for a tutorial I'm going to do on driving OLEDs, is that this was the cheapest one I could find. So this OLED module was just £3.77. This came from OK Cat Fair. Yeah, that's free postage. As I say, that was the cheapest one I could find on eBay. It might be a while before I get around to actually getting this thing working, because the I2C interface makes it a bit more complicated than using the SPI type. But I'll do it eventually. And so that is today's Postbag.